Good evening. My name is Eli Kwizera. I'm a student of AIMS Rwanda, and I'm going to present on my project in statistical machine learning. So basically, my assignment, I've been given data, and I want to perform machine learning and to compare the models to see what is the model which is appropriate for my data. So here, data exploration. Here I've been given data called AIMS Rwanda. AIMS SMR 2024-2025, and I've been 225 observations. So I performed the scatter plot versus it's y versus x. So my data set was included two variables. One was y and another one was x, which was independent variable. So here, as you see in this plot, my scatter plot shows that there is no relationship between this variable. As you see here, you cannot find what is the relationship between these variables. And also, I choose the regression task since I have found that the response variable is continuous. So in this case, we are going to deal with a regression task, not the classification task. Okay. And here I have a theoretical framework. My theoretical framework, I have introduced the function space, loss function, the theoretical risk. As you see here, there is a bias running machine and the empirical risk. So in this part 3, I've been asked to find the estimation of the model complexity. So where the model have the complexity. So here I have found that I have transformed my data into my variables in a form of matrix, as you see here, and then I estimate my parameters by using a least square estimates. So to determine the optimal complexity, which model is a good, here I plot in R. So this is my code for plotting the which I'm sorry. This is the code that shows that calculate the model the optimal degree. So here I get 10. This is the degree that can that our model can work well. So here I choose to use the polynomial model in order to fit this my data well. I've been plot the cross validation error versus empirical risk. So as you see here, the cross validation error is this one which is labeled as red, a red one, but the blue one is the one which is empirical risk. As you see here, so this red one it is over, but this blue one it is below. It is below one. So here, this plot it indicates that where where there is a cross validation error, this our cross validation error, it identify the degree where the error is minimized. So but the empirical risk also decreases as p increase, as you see here. In part 4, I've been asked to do comparison in the models. So here, this is the code in R. So I want to show you what I have get. In model comparison, I have get 3 models. I wanted to compare simple model, optimal model, and the overcomplex model. So here I have seen that this simple model, as you see, it is the simplest, so it cannot perform well. But when it comes to this optimal model, as you see, it is somehow fitting our data, even if it is not 100%, but you see it is fitting our data. So this red one, it is the complex model. It is over. When you zoom this, And when you see clearly in R, you see that this complex, it is the overfitting. So we cannot choose this model. We choose the optimal one. This is the code in R that shows the error for different models. So as you see here, we have the model of optimal, over complex, and simplest. So here, as we have seen that before, that this optimal, it is the one that fit our data. Well, if you see on this plot. So for further analysis, I'll perform ANOVA. So this ANOVA showed me that if you see on this p-value, it is less than 0.05. So it showed me that there is a highly significance between these models. So these models are not the same. Where I have stated that this null hypothesis was to I was assuming that these models are the same, but I have found that they are not the same. This is the confidence and prediction bonds, and this is the graph that shows my confidence and prediction bands. So as you see here, it is lying between -0, -1, sorry, and 1. So and this is the graph that shows my confidence and prediction bands. So here there is some mathematical expression for that one, as you see. But for the sake of time, let me please go to exercise 2. Exercise 2, I've been given to find to find to deal with the data buried in R called spam. So this is the spam. So I've called my data. Here you see it is a spam, and I have put this is I'm sorry, this is the variable that we have in a spam data. So as you see here, our dimension, we have observation of 4,601. But you see, we have also independent our variables, which is 58. So so we have non-spam, which is 2,788, where the spam is 1813. So this is the distribution of my response plot, where this distribution shows the spam and non-spam, how they are rating. So you see that this non-spam is higher than the spam. So this include that there is an unbalance. This is our sample size and the dimensionality. I've said that. So our sample size is 4,601. Dimension is 50. Dimensionality, we have 57 predictors. So this is the LOC curve I have found, where I have been asked to see which model is good. When I want to compare the model which is good between RDA, sorry, this is machine, RDA, QDA, naive Bayes, and FRD. So as you see here in this plot, this red one, it is RDA as labeled in this below here. So I want to say something on this. The LOC curves highlight the comparative performance of the model, which with the area under the curve AUC, indicating which model perform best in distinguishing between the spam and non-spam. So here there is stochastic hold with 50 replications. This is the code, or in R. So I want to show you a plot. So this is the test error for models. So where you see this one is FRD, as you see here, as a labeled. So the best model here, as you see here, is FRD. So FRD, this our FRD is the best the best machine that we can use. So this is the model that we have to use, because it is the one that shows us there is no huge variation, and it approximates the best value. So this is some comments, but to conclude, uh, this is some comments on this plot. But to conclude, this task and this machine learning is a good in a real life. So we have to implement them to find the solutions, to the problems that we have. So if you have data, you can perform machine learning to analyze your data well. And sometimes people struggle to use classification and regression. But in this mode, in this, we have seen that if you have a response variable, we use regression. It is our regression task. But when it comes to categorical, you see, and non-continuous, we use classifications, or when it is when it is a binary. So I thank you so much. Thank you for your attention.